Okay, let's unpack this. Welcome to the deep dive, where we try to cut through the noise and get to what really matters.
Mhm.
Today, we're plunging into a world that's, well, often out of sight, but absolutely critical for the planet. Sustainable textile machines. Think about the global push for eco-conscious fabrics. It's huge, right? And it's really driving manufacturers to adopt some pretty advanced machinery really quickly. So our mission today, give you the inside track on how the textile industry is getting greener, faster, more efficient, with some genuinely surprising facts along the way. We're going to take a journey, basically, right through the production line, from like the raw fibers all the way to finished fabric and even recycled fabric. And here's a little hint of something cool we'll dig into. There's this unsung hero material, aluminium, that's quietly enabling a lot of this innovation, especially when it comes to speed and sustainability. So, yeah, get ready. Now, here's where it gets, I think, really interesting. Why has sustainability become such a critical thing in textile production, not just, a buzzword anymore? We've heard about it for years, sure. But what are the real deep down reasons for this massive shift happening right now?
That's a great question. And the answer really comes down to understanding just how resource-hungry traditional textile manufacturing has always been. I mean, historically, the industry used staggering amounts of water and energy, left a pretty big environmental footprint. But today, the shift towards sustainability, it's being driven by, I'd say, five key things that are all connected. First, it's really about making a tangible difference to our environmental footprint. You look at modern machines, especially in printing and finishing, they're actually engineered now to use eco-friendly inks and way, way less water. And this isn't just some vague, cleaner production idea. We're talking like reductions in chemical oxygen demand in wastewater by over 70% in some cases. That's a massive leap from the old ways.
70%. Wow, okay.
Yeah. Second, there's this intense focus on energy efficiency through smart machinery. These machines aren't just a little bit better. They're designed from the ground up for optimal energy use and minimal waste. And what's really fascinating here, and often gets missed, is how the basic material choices make such a difference. Take aluminium, for instance. It's not just picked for its high strength to weight ratio, which is great for components, obviously, but its thermal conductivity is exceptional. That means it allows for really rapid, precise temperature control in critical machine parts. So less energy wasted heating and cooling, more stable temperatures. It's a kind of silent boost to efficiency, especially in those really fast, demanding environments.
That makes sense. Lighter and better with heat.
Exactly. Third is much more sophisticated waste minimization. Advanced textile machines now use things like computer numerical control CNC for precision patterning. Add in highly automated controls, and you get incredibly low error rates, which means much less material gets rejected before it even leaves the machine. Just think about the waste from tiny inaccuracies over millions of meters of fabric. These improvements make a colossal difference.
Right, preventing waste right at the source.
Precisely. Fourth, compliance with global standards isn't really optional anymore. It's basically your ticket to play in global markets. Eco-conscious machines. They're designed to meet really strict international norms, like GOTS, that's the Global Organic Textile Standard, and OECOTEX, which checks for harmful substances. For brands and manufacturers, meeting these is just vital for market access, for consumer trust, for their whole reputation, really.
Yeah, you see those labels everywhere now.
You do. And finally, number 5, it comes down to long-term cost savings. Okay, maybe sustainable machinery costs more upfront, potentially, but it significantly lowers your running costs over its life. Think about components made with corrosion-resistant aluminum extrusions, for example. They need way less maintenance, last much longer, especially in those chemically tough environments like dyeing. And that translates directly into real savings, lower energy bills, less upkeep. It adds up.
That's a really powerful case. It hits the environmental needs and the economic ones. Okay, so with that background, what does this actually look like on the factory floor? Let's kind of walk through the production line, see the specific machines driving this green revolution, starting right at the beginning with spinning. What's happening there?
Right, spinning. Well, the basic job is still converting raw fibers, natural synthetic, into usable yarn. Drafting, twisting, winding, that's the core. But the big innovation now is how well they handle really diverse and, frankly, challenging materials. Modern machines can get amazing consistency, even with stuff like recycled polyester or organic cotton. They use advanced sensor arrays that dynamically adjust the drafting ratios. This overcomes the variability you often get with recycled fibers, which used to limit their quality and how widely they could be used.
So it's not just using recycled stuff, it's making high-quality yarn from it. That's huge for making circularity actually work, isn't it?
Exactly right. A lot of manufacturers are now specifically offering spinning lines designed to be fully compatible with these recycled and organic materials. It directly supports those closed-loop models that consumers are increasingly asking for.
Okay, so we have this incredibly precise, sustainably spun yarn. Next step, turning it into fabric. That brings us to weaving machines or looms. How are they getting greener?
Yeah, looms, they take the yarn, make the fabric, and different types have different green benefits. You've got rapier looms, they're super versatile, handle lots of different fabrics, and they're pretty energy efficient. Then air-jet looms, incredibly fast, which means less labor needed and great for synthetics. Even water-jet looms, which, okay, use water, but they've been really optimized now for minimal consumption. Lots of water recycling built in, that's key.
Right. And it's not just the type of loom, is it? You mentioned smart features, IoT, AI. How exactly are they making weaving more sustainable?
This is where it gets really clever. So IoT sensors, for example, they aren't just monitoring things. They're predicting tiny filament breaks on super fast air-jet looms hours before they happen.
Wow.
Yeah. So you shift from reacting after waste has already happened, stopping the machine losing fabric, to predicting it. You get near zero waste operation in that sense. And think about the forces involved in modern looms, the speed. You need incredible structural stability. And this is where those advanced frames, often made from lightweight but really stiff aluminum extrusions, are critical. They soak up vibrations, keep everything perfectly aligned, ensure consistent tension, which directly impacts fabric quality and cuts down material waste at those high speeds.
Okay, fascinating. So from woven, let's talk knitting. Knitting machines are key for sustainable garments, partly because they can inherently create less waste, right? For activewear, industrial fabrics, all sorts. What are the innovations?
Well, the beauty of modern knitting is really its precision. Doesn't matter if it's weft knitting for your stretchy fabrics or warp knitting for more stable stuff. Advanced machines give you incredible control over the fabric's density, its texture, and digital patterning, computer-aided design, they slash the amount of offcuts.
How so?
It's not just about avoiding making too much fabric, it's about designing garments sometimes with patterns that interlock perfectly on the knitting bed, leaving almost zero waste. It's a totally different way of thinking compared to traditional cut and sew.
So the design itself becomes part of the sustainability strategy. Clever.
Yeah.
What about machine parts? Any key components there?
Definitely. A really good example is ceramic guides for the yarn. They massively reduce friction and yarn breakage. Now, that doesn't just mean smoother running. It means less energy lost as heat, less downtime for repairs, and the machine itself lasts longer. It all boosts energy efficiency. And you mentioned seamless production. Circular knitting machines are really pioneering that. They can create whole garments with minimal or even no sewing needed. That cuts way down on trims, waste. Perfect for that comfy, sustainable fashion people want.
Okay, fabric formed. Now, for what's often the most resource-heavy bit, dyeing and finishing. This is where water and chemical use really comes under scrutiny. What are the breakthroughs here?
Oh, this area is huge for innovation. The progress is really impressive. We're seeing waterless technologies now, like Keo dyeing systems. They literally use carbon dioxide instead of water. They reuse the cereals, need way fewer chemicals. It's brilliant. But the real genius of seer dyeing isn't just zero water. It's that they get incredible color fastness and consistency, especially on synthetics like polyester. That used to be a real headache with water-based dyeing, often needed re-dyeing to fix patchiness, which meant loads of hidden waste.
That is a massive leap. Better quality and no water. Okay,
Yeah.
What else is happening in eco-friendly dyeing?
We're also seeing lots of enzyme-based and low-impact dye systems being adopted. These basically swap out harsh synthetic chemicals for biodegradable alternatives. That dramatically cuts the pollution load going into wastewater treatment. And automation is key here, too. Smart dyeing machines monitor and control everything in the dye bath in real time, cuts down human error, optimizes how much chemical is used, means less reprocessing, less over-dyeing.
So less water, fewer chemicals per bath.
Exactly. IoT-enabled controls are pretty much standard now for that level of precision. And actually, in these tough chemical environments, we're even seeing things like internal guide rails, which used to be heavier, less resistant materials, being swapped for special aluminum alloys. Last longer, less downtime.
Right, the material science aspect again. Okay, then printing, bringing the visual design to life. How are machines making printing low waste and high efficiency?
Yeah, printing. The contrast between digital and traditional screen printing is, well, it's stark. It's a real aha moment. Traditional screen printing needs a separate physical screen for every single color. That means loads of material waste just setting up, plus tons of water to clean the screens afterwards.
Okay.
Digital textile printing, it just gets rid of the screens entirely.
So right away, less waste from making screens, faster setup, hardly any water compared to cleaning all those screens. Plus, you get high-res designs on demand, which must mean less need to print huge batches, less risk of overstock and unsold goods. That's a big win for the whole fashion supply chain, surely.
Exactly. That's a huge sustainability benefit right there. And the inks themselves, eco-friendly, water-based and pigment inks aren't just common now, they're getting better all the time. Lots of machines support Go ETS and OPTEX compliant inks, making sure the final product is safe and green. Plus, you see innovations like clever ink recovery systems, energy-saving curing units. It's all about closing the loop on waste and energy.
Okay, connecting all these pieces. The final type of machine really takes sustainability full circle, doesn't it? The recycling and reprocessing machines. These seem pivotal for genuine closed-loop systems.
Absolutely. They are basically the engine of a circular economy for textiles. These machines allow for advanced fiber regeneration. They can recover and regenerate fibers from both pre-consumer waste like factory scraps and post-consumer waste like old clothes. This lets mills feed high-quality recycled fibers back into manufacturing, which drastically cuts the need for virgin materials. That's a total game changer for resource use.
And it's more complex than just shredding, right? There are specialized machines that take cutting scraps, offcuts, even damaged fabric, and turn them back into usable yarn and fabric that still meet high standards, aesthetically and functionally. That sounds challenging.
It is challenging, and that's where the engineering brilliance really shows. Their role in the circular economy. You can't overstate it. By enabling this constant reuse and transformation of textile waste, these machines genuinely foster that circular approach. And here, too, components matter. Things like ceramic guides provide the durability and precision needed to handle those often tricky, variable recycled fibers smoothly, keeps the machines running longer, makes the whole system more sustainable.
Wow. Okay, this walk through the production line has been incredibly eye-opening. It's really clear the future isn't just about doing less bad. It's about fundamentally rethinking every single step. So boiling it all down, what does this mean for you, the listener? If you're a manufacturer, maybe a supplier, or just someone curious about fashion's future, what are the absolute non-negotiables, the must-have features in truly sustainable textile machinery today?
Yeah, good question. I think it comes down to 4 critical things, and they all connect. First, prioritize advanced energy efficiency and automation. Look for machines that don't just use less energy, but optimize it with smart systems, automatic fabric feeds, real-time production controls. We're talking measurable drops in kilowatt hours per meter of fabric.
Right.
That shrinks the carbon footprint directly.
Okay, efficiency and smarts. Got it.
Second, demand cutting-edge water and chemical conservation systems. Top-tier machines now have sophisticated water recycling, super precise chemical dosing, intelligent rinsing cycles, even totally closed-loop chemical systems. These things drastically cut waste and improve accuracy. Sometimes you see like a 95% reduction in processed water compared to older tech. It's huge.
95%.
Wow.
Okay, number 3.
Third, smart sensors and IoT integration. Honestly, this isn't a luxury anymore. It's a must-have across all types of textile machines. IoT components give you real-time data, predictive maintenance fixing problems before they cause downtime and performance optimization for the whole line. It streamlines everything, ensures quality, helps prove you're meeting sustainability standards. It enables data-driven decisions.
Makes sense. Data is king. And last one.
And finally, number 4. Look for low-emission or closed-loop systems. Machinery designed with low-emission burners or totally closed-loop exhaust systems drastically cuts air pollution and stops energy from just escaping. And here again, our unsung hero material, aluminum, really shines. Lightweight, modular aluminum extrusion frames. They're great for heat dissipation in these systems, which is key for efficiency. And they lower the machine's overall environmental impact right from its construction.
Wow. What a deep dive. Seriously, it's truly inspiring to see how this constant evolution in textile machinery, spinning, weaving, knitting, dyeing, recycling, it's all driving genuinely sustainable and high-efficiency fabric production. It's not just tinkering around the edges. It feels like a fundamental rethink of every single step, from the raw material right through to end of life.
Absolutely. And you really can't overstate the critical role of both that innovative machine design and the precision engineered materials like aluminum that make it possible. It's the combination, the synergy that enables cleaner, smarter, and ultimately more circular fabric production.
So what does all this mean for you listening? Well, maybe next time you pick up a piece of clothing, just take a second. Think about the incredible, often invisible journey it might have taken. From that raw fiber through super smart spinning, weaving, knitting, dyeing, printing, maybe even being born again from recycled stuff.
Yeah.
The machines working behind the scenes are truly transforming what's possible.
And, this raises a really interesting question for the future, doesn't it? As this technology enables truly closed-loop systems where fibers get regenerated, waste gets endlessly reprocessed, how will our whole relationship with clothing ownership and disposal fundamentally change? Will the very idea of new clothes, as we've always known them, maybe become, well, a bit of a relic, replaced by an appreciation for resources that just keep circulating?
That is a truly provocative thought to chew on. Thank you for joining us on The Deep Dive. Keep that curiosity sparking, and we'll catch you next time.